Welcome to chapter number 3 under Codes and Triangle, 11th edition, Balancing Chemical Equations. In this particular unit, we will be studying balancing chemical equations and then seeing how to write chemical equations and then finally introduce chemical equilibrium. Here is the basic objective and student learning outcomes. You need to understand what is conveyed by a balanced chemical equation, the terminology used, recognize a balanced chemical equation, what is the law behind it, balance simple chemical reactions, recognize that all chemical reactions are reversible and that eventually they'll reach a dynamic, a dynamic equilibrium. Recognize the difference between reaction-favored and product-favored reactions. A reaction is shown below in words and in symbolic representation. You see, the word description is that methane reacts with oxygen to yield carbon dioxide and water. The symbolic representation is you write the formula of the reactants and the products. Methane gas has the formula CH4 plus 2 oxygen. The arrow indicates yields, and CO2 and 2H2O are the products that is obtained. Generally, when writing a chemical reaction, we tend to include the states of all the compounds that come out. So we have CH4 is a gas, O2 is a gas, CO2 is a gas, and H2O is a liquid. And compounds on the left of the arrow are called as reactants, and compounds on the right are called as the products. The relative amounts of each are given in a reaction, and the numbers in front of each compound is the stoichiometric coefficient. The law of conservation of matter. The same number of atoms is present in a reaction at the beginning and at the end. The amount of matter in a system does not change. Hence, when heating mercuric oxide, you will find that the reaction will give oxygen gas is produced as well as 2. If you take 2 moles of HUO, you will get 2 moles of Hg liquid and 1 mole of oxygen gas. The principle behind this particular reaction or balancing chemical equations is that the mass must be conserved. That means the law of conservation is matter is applied. In other words, matter can neither be created nor destroyed. Therefore, the number of atoms on each side of the balanced equation must be the same. Now, what it means to balance and what are the steps that are involved in balancing the chemical reaction? Since matter is conserved in a chemical reaction, chemical equations must be balanced for mass. That must be the same number of atoms of each kind on both sides of the equation. Once the equation is written, give the symbolic representation. The subscripts of the reactants and products cannot be changed. To satisfy the law of mass or conservation of mass, coefficients are used to balance the equation. So what must one do? Write an equation using the formula of the reactants and products. Include the physical states, solid, liquid, gas, AQ. Balance the compound with the most elements in the formula first using integers as coefficients. Balance elements on their own last. Check to see that the sum of each individual elements is equal on each side of the equation. If the coefficients can be simplified by dividing throughout with a whole number, do so. The second method is, of course, a trial and error method, and usually faster for simpler Maulic equation than for more systematic approaches. But you have to remember that a chemical reaction is a chemist's shorthand to describe a compound. So when we describe a compound using the chemist shorthand, it has all the reactants, their formula, their states, and the states of all the substances. Any conditions used in the reaction must also be provided. For example, the decomposition of a calcium carbonate on heating. Now you have to remember that the chemical equation must have the same number and the type of atoms. So on the left-hand side of this equation, you see calcium carbonate on heating. On the right-hand side, you see the products CaO and CO2. If you add up all the atoms, there is one atom on both sides for calcium, one atom of carbon on both sides, and 3 atoms on the product side and 3 atoms on the reactant side. Therefore, the reaction is balanced. Now consider another equation, C2H6 plus oxygen gas gives you carbon dioxide and hydrogen. First, balance the H. So we have C6, but in water there is only 3, 2 H2O. And so you write 3 in front of H2O. So this will give you the coefficient for water. There are 2 carbon dioxide, so put 2 in front of it. And then we have to balance the oxygen. But 3 oxygen plus, on the product side, there is an odd number of oxygen, while on the reactant side, there is an even number of oxygen. Therefore, what we have to do is multiply throughout by 2 to make sure that you have the correct number of oxygen atoms. Once you balance the oxygen atoms, then do a check to ensure that all the atoms on both sides of the arrow are the same. And this is another one. You can do it by yourself. And then we have a set of balance equations. Try and balance them without seeing the answer. The answer is given at the bottom. And then beyond this, we have some self-study questions. Go through it and make sure that you know which to identify a balanced equation, identify a balanced equation for combustion, then combustion, so that it's like a review for you. Next, we go to chemical equilibrium. When writing chemical reaction, one starts with the reactants and products. The reactants are on the left side and products are on the right side. Some reactions can also be written in the reverse. For example, N2 plus 3H2 gives you 2 NH3 gas, and 2 NH3 gas can break down into nitrogen gas and 3 hydrogen gas. And this, both, if you combine both the reactions together, we can write it with a double arrow indicating that the system is in equilibrium. Now, the reversibility of a chemical reaction. Now, we can, any chemical reaction in equilibrium can be reversed or made to go in one direction if you add certain chemicals or remove certain chemicals from one side. And so in this, the reactants on the left-hand side are sodium chloride and ammonia. On the left-hand side are calcium chloride and sodium bicarbonate, which consists of the calcium ion and the bicarbonate ion. And on the right side, as soon as you mix them, you see that a product of, you can see the fizzing of carbon dioxide and the slurry of calcium carbonate. Now, if to this reaction you just pump in some carbon dioxide and bubble through the solution, through the slurry, you find that the solution has turned back clear, thereby reversing the reaction because the calcium ion and the bicarbonate ion do not have any color. And now you have again a set of self-study questions that are there. Please go through each self-study question in order to ensure that you understand the concept of dynamic equilibrium and how to balance a reaction. And with that, I'm going to stop the presentation.